Paris Hilton visited Paris for Apple. Read that sentence. Now tell me, which Paris is the person, which is the place, and what kind of apple are we talking about? The fruit? The record label? The tech company? A human reader gets all three in about a second. A named entity recognizer has to make 3 ambiguity calls in a row without breaking a sweat. Video 5 of Lecture 7, Named Entity Recognition, also known as NER. The task of pulling proper names, people, places, organizations, money, dates, out of raw text. The task every information extraction system starts with, and the task where deep learning changed the ceiling overnight. In video 4, we drew the sentence's skeleton. Now we know which words are subjects, verbs, objects. Great, but the parser doesn't tell us the difference between Paris is the person and Paris is the city. Both are NNP, proper noun. Both play the same syntactic role. To an NER model though, they're completely different categories. 4th station on the belt. Today's puzzle. NER sounds simple. Look at a proper noun, decide what type of thing it is. Except, most named entities are more than one word. Multi-word spans. New York City, Bank of America, Elon Musk. You need to know where an entity starts and where it ends. That's the deep insight the field solved with BO tagging. Today's 3 beats. First, biotagging. Ramshaw and Marcus, 1995. How to turn span extraction into per-token classification. Second, the CoNLL 2003 shared task. 4 entity types, 1 benchmark, 20 years of comparison. Third, how BERT-based NER works. Contextual embeddings, fine-tuning, 93 phone on English. Beat 1. Biotagging. Ramshaw and Marcus, 1995. The trick that made NER a solved framework. Every token gets one of 3 tags. B for beginning of an entity, I for inside an entity, O for outside any entity. Then you concatenate the type. B per for beginning of a person, I per for inside a person, BLOC for beginning of a location. 9 tags total in the standard scheme. Suddenly span detection is per token classification, which every ML model can do. Why not just tag each entity with its type? Because entities are contiguous spans, and B versus I encodes the boundary. Without it, 2 adjacent entities of the same type would fuse into one. Elon Musk fired Jack Dorsey. Without the B tag, a naive tagger might merge Elon Musk with Jack Dorsey into one superperson. BO forces the model to say, new entity starts here. Beat 2. The CoNLL 2003 shared task. Cheong Kim Sang and D. Milder. Newswire text from Reuters. 4 types. PER, ORG, LOC, MISC. Person, organization, location, miscellaneous. 14,000 training sentences. And a hidden test set that everyone competes on. 20 years later, CoNLL 2003 is still the yardstick for English NER research. First generation NER on this benchmark used handcrafted features, word shape, capitalization, suffixes, gazetteers, big lists of known names. Feed those into a conditional random field, around 90 phone. Not bad. But feature engineering was brittle. A model trained on Reuters didn't generalize well to tweets, medical text, or legal documents. Second generation NER. Lample and colleagues, 2016. A bidirectional LSTM with a CRF layer on top. Word embeddings and character embeddings instead of features. 91 phone. Better generalization. Then Devlin and colleagues shipped BERT in 2019. Fine-tuned BERT on CoNLL, 93 phone, new state-of-the-art, and the same architecture works for medical NER, legal NER, tweets, whatever, just fine-tune on domain data. Beat 3. How does BERT NER actually decide Paris is a person or a location? It doesn't have a rule book. It has embeddings, 1 per token, that already encode context. If the sentence around Paris talks about hotels, celebrities, Instagram, the vector for Paris looks person-ish. If the surrounding sentence talks about the Eiffel Tower, croissants, or the Seine, the vector looks location-ish. A linear classifier on top of the embedding then predicts the tag. The hard cases. Nested entities. Bank of America Stadium. Is that one ORG or an ORG inside a LOC? Cross-type ambiguity. Washington the person, the state, the DC city, or the football team. Emerging entities. New names the model has never seen. Modern NER handles the first two well. New entities are the ongoing research problem. NER is not just pure ORG LOC anymore. Modern schemes go wide. Ontonotes has 18 types. Legal NER models tag statutes and case citations. Medical NER models tag drugs, symptoms, and gene names. When you build an information extraction system, the type inventory is your first design decision, and every downstream task depends on it. Practical picks. Production general domain. Spacey or stanza both ship pre-trained NER with the Ontonotes types out of the box. Legal or medical. Use a domain-specific pre-trained model. If you're building custom NER, fine-tune a BERT or Roberta on your labeled data. If you have 20 labeled examples, try few-shot prompting with an LLM first. Cheap first pass. 3 takeaways before the quiz. 1. Bio-tagging turns span extraction into per-token classification. B for beginning, I for inside, O for outside. Ramshaw and Marcus, 1995. 2. CoNLL, 2003 is the still-standing benchmark. 4 types. Reuters newswire, 20 years of comparison across every NER paper. 3. BERT-based NER hits 93 phone by using contextual embeddings. Same Paris, different vector, different tag. And the architecture transfers to any domain via fine-tuning. Quiz 1. Why does NER use BPER and IPER instead of just tagging every person token as PER? A. It's shorter to type. B. Without the B tag, 2 adjacent same-type entities would merge into one. Elon Musk fired Jack Dorsey would collapse into a single-person span. C. BERT requires it. Or D. CoNLL 2003 mandated it. B. The B marks a new entity boundary. Without it, Elon Musk fired Jack Dorsey looks like a 4-token person to the tagger. The B says, new entity starts here. Ramshaw and Marcus 1995 invented this scheme and it's still the default. Quiz 2. What are the 4 entity types in the CoNLL 2003 shared task? A drug, symptom, gen dosage. B. Per ORG LOC MISC. CNN. VB, JJ, RB, or D happy, sad, angry, neutral. B. Person, organization, location, miscellaneous. Chong Kim Sang and Day Mulder 2003. Reuters newswire. 14K training sentences. Still the benchmark 22 years later. Quiz 3. How does a BERT-based NER model decide whether Paris is a person or a location? A. It looks the word up in a dictionary. B. The contextual embedding for Paris is different depending on the surrounding sentence. A linear classifier on top decides the tag. C. It always picks the most frequent tag. Or D. It asks a large language model. B. This is the whole point of contextual embeddings. The vector for Paris in Paris Hilton lives near person-ish vectors. The vector for Paris in Paris has the Eiffel Tower lives near location-ish vectors. Same input token, different output vector, different tag. Back to the puzzle. NER pulls out the who, the where, and the how much. Bio tags encode spans. CoNLL is the benchmark. BERT is the modern engine, 4th station done. But knowing Paris is as a location doesn't tell you what SEOs of bank someone meant, riverbank or financial bank. That's word sense disambiguation. Video 6. Next time, word sense disambiguation. Which bank did you mean? The river or the financial? Miller's WordNet, the LESC algorithm. And why contextual embeddings quietly solve this task without anyone announcing victory? Hit subscribe.